Good morning all. Welcome to today's experiment. The title of the experiment is Study of Magnetic Field along the axis of circular coil by using Stewart-Gauge method. So this can also be called as Stewart-Gauge method or Stewart-Gauge apparatus experiment. So the aim of the experiment is to study the variation of magnetic field along the axis of current carrying coil. So the apparatus required for this experiment are deflection magnetometer, circular coil along the axis. Next thing is the possibility of selecting the number of turns in this circular coil. We have these 4 adjustments. This is called as commutator, ammeter, battery eliminator and rheostat and connecting wires. So these are all the apparatus required for this experiment. Now I will explain each and everything clearly. So first one is, this is called as deflection magnetometer. So in this we have, this also acts as a compass. So in this we have aluminum pointer to know the deflections, and second one is the magnetic needle. So on the magnetic needle we have an orange dot. So this orange dot always indicates the geographical north. So in this particular room, as dot is in the upward direction, we can say that the geographical north for this room is in this upward direction. So the downward is south, and here it is in the eastward direction and the westward direction. For this particular experiment, we are doing the variation along eastward and westward directions. So this is about the deflection magnetometer. I'll repeat again, aluminum pointer will give you the strength of the magnetic field that is created, and the magnetic needle to know the geographical north, south, east, west directions. Next one is, this is a circular coil, means a coil wounded over and it is insulated tape. So the number of turns on this circular coil can be selected by using either of these knobs. So if you see this, 5 indicates, if I connect these two, 5 turns on this coil can be selected. Suppose if I select this 50th turn, so I am selecting 50 turns on this circular coil, and if I connect for this 500 terminal, I am going to select 500 turns on this circular coil. Like this, based on our requirement, we can select either 5 turns, 50 turns or 500 turns. So in this particular experiment, now we are selecting the 50 turns. So while connecting, you should be careful enough that first wire should be connected to the first knob, and second wire can be connected either 5 or 50 or 500. That means it tells us that we are connecting right from the first turn to the 50th turn. Suppose if I select any of these two, like if I connect for 5 and 50, I am neglecting the first 5 turns, which is not correct. That's why we have to select the first knob as a compulsion connection, and second turn, second connection to either 5 or 50 or 500th terminal. But in this experiment we have connected for 50 turns. Second thing is, how we have to create a magnetic field. Are we using a magnet? Means in this particular experiment we are not using a direct magnet. Instead we are creating the magnetic field by passing current through this circular coil. Means you all know that according to Biot-Savart's law, when current is passed through a circular coil, a magnetic field is developed. So our aim is to pass the current through this circular coil. Now to pass the current through this circular coil, we have the remaining equipment in this particular experiment. First thing is, we have to create the potential difference to these turns of 50 turns of this circular coil. So to create the potential difference, by the knowledge of your previous experiments, you all know that the red terminals will indicate the positives and the black terminals will indicate the negative. So somehow we need to create this potential difference between the 2 turns or between any 2 ends of the circular coil. So that's why we are using this battery eliminator. Second thing is, when current is passed through the circular coil, we should know how much of current is passed through the circular coil. For that we are using this ammeter. So in the ammeter, you all know that there are two types of meters. One is the digital meters and other one is the analog meters. So in your earlier experiments like LEDs, we have seen the digital meters where the values are directly displayed. But when you see the analog meters, we have to calibrate the scale. So calibrate the scale means first you should know, whenever this type of analog meters are given, first you should know what is the range of the meter, and second one is what is the calibration of this meter. So range is nothing but the minimum to maximum value, how far it can measure. So this particular ammeter is measuring between 0 to 3 amps. See here 0, 0.5, 1, 1.5, 2, 2.5 and 3. So the range of this ammeter is between 0 to 3 amps. Likewise, each analog meter has its own range and its own calibration. So whenever these meters are given to you, the first thing you need to do is to find its range as well as its calibration. Now the range of this particular ammeter is between 0 to 3 amps. Second thing is calibration. So calibration means you don't know what is the value of each black line in between 0 to 0.5. So how can you know the value of each division? Means you need to know one formula like what is the first calibrated value and how many number of divisions are there from 0 to the first calibrated value. So in this meter, the first calibrated value is 0.5 amps. Next thing is from 0 to 0.5 we have 10 divisions. You count it, we have 10 divisions. So the formula is the first calibrated value by the number of divisions. So the first calibrated value is 0.5 and the number of divisions are 10. So 0.5 by 10. So each value is 0.05 amps. So 0.05 amps. I'll see here 0.05. So how will you get that 0.05 means the first value is 0.5 and the number of divisions are 10. So 0.5 by 10 is nothing but 0.05 per division. So this is the calibration. So I'll repeat again, the range is 0 to 3 amps and the calibration is 0.05 per division. Next thing is Riostat. So the use of this Riostat is to offer the variable resistance in this circuit. So what is meant by this variable resistance means in some of the experiments we have used the resistors. Say for example, if we are using 100 ohm resistor means always it will offer approximately 100 ohms of resistance, more or less plus or minus 1. But here you can vary the resistance from 1 ohm to 10 kilo ohms in this for this particular experiment by varying this knob. So this is known as variable resistance called as Riostat. So in the Riostat we have 3 connections. This is called as center tap connection, first terminal and second terminal. So in most of the experiments we can use either these two or these two. So center tap is a must whenever we use a Riostat. So one connection or one end of the circuit has to come to the center tap, and depending on our requirement we can select either the first knob or the second knob. What is the difference means if you select the first knob, for particular ranges we can adjust the Riostat. But if you select the end to end connection, entire range from 1 kilo ohm to 10 kilo ohm resistance can be offered to this circuit. So always remember, in most of the circuits we require end to end connection. First end is the center tap connection, second end is the extreme end. So this is known as Riostat, which offers the variable resistance to the circuit. And the last device in this circuit diagram is known as commutator. So the purpose of the commutator is to reverse the flow of current across the circuit. So what is the need of this commutator means, you all know that this is a circular coil. When current is passed through the circular coil, we just now came to know that a magnetic field will be created, and the strength of the magnetic field is indicated by this aluminium pointer. Now they got a doubt like, if I change the reverse or if I reverse the flow of direction, means if I pass the current in one direction like clockwise and if I pass the current in the anti-clockwise direction, what will be the effect of the magnetic field? To clarify that, instead of rearranging the circuit from clockwise to anti-clockwise, we can use this commutator which will reverse the flow of current based on the selection of these knobs. So the commutator is simply a combination of 4 plug keys. So this is one plug key, first plug key, second, and this is third and this is 4. Means we can say that the 4 plug is connected. This is the use of the commutator. Now how to operate this commutator means you should remember that in the commutator 2 opposite ends make one pair. Means we are connecting these 2 opposite ends and we are opening the circuit in the other end. Now if I want to reverse the flow of current, I just break this circuit and reconnect in the opposite ends. So in commutator always the opposite ends make one pair. So these are all, and to connect all these components we require the connecting wires. And to remember, everywhere the black terminals will represent the negative and the red knobs will represent the positive terminals of that particular device. So I hope you have all understood about the each and every element or device that we are using in this circuit diagram. Now we need to connect the circuit. So this is the circuit diagram given in your manual book. So this is the circuit diagram. So in connecting this circuit diagram, let us start with the commutator point. So commutator is, this is the commutator having 4 knobs. So here this is very much similar. These 4 knobs are shown in this. As I said, 1 and 2 make one pair and 3 and 4 make one pair. Just for our understanding, let us number it. Now you see this. When you see these connections, see here, the third connection is going to the circular coil. Similarly, the opposite one, fourth, is also going to the circular coil. Means 2 ends of the commutator are connected to the circular coil and the other 2 ends like 1 and 2 if you see, the rule is to go in the clockwise direction. So second is connected to the plug key, ammeter, battery eliminator, rheostat, and the rheostat second end is connected to the commutator first end. Means the first 2 opposite ends we are giving it to the coil and second 2 opposite ends we are connecting the remaining components of the circuit. Now just like as shown in the circuit diagram, let us connect the circuit diagram by using the real components. So if I start from the commutator, between 3 and 4 we are connecting the coil. See here, between 3 and 4 we are connecting the coil, selecting the 50 turns. Just for your understanding I will show you. So the third connection is connected to one of the ends of the coil. And the opposite one, this is the opposite one, so that is connected to the first end. So commutator 2 ends are connected to the 50 turns. Next, the other 2 ends we are connecting the circuit. So if you see the other 2 ends, see from second terminal we are directly giving up to the ammeter. No need to connect this plug key. So we can say that second key of the commutator is connected to the battery eliminator positive. Ammeter positive. So second key we are starting with the first 2 ends are connected to the circular coil. From these 2 ends we are connecting the rest of the components. The first connection is to the ammeter positive. We have connected to the ammeter positive. Next, from ammeter negative to battery eliminator negative. Ammeter negative to battery eliminator negative. See here, battery eliminator negative, black knob. Next, battery eliminator positive to rheostat, battery eliminator positive to center tap. Battery eliminator positive to center tap. Next, rheostat second end to the commutator. Rheostat second end to the commutator opposite end. We started from here and we ended up over to the opposite end. So rheostat second end to the commutator end. I'll repeat the connections. 2 ends to the circular coil. From the commutator you start with any of the end to the battery eliminator. Ammeter positive, one end to the ammeter positive, ammeter negative to battery eliminator negative. Next, battery eliminator positive to center tap of the rheostat, rheostat second end to the commutator other end. So we have finished off all the connections according to our circuit diagram. Now the procedure is clearly given in your manual book. You can read. The first part of doing this experiment is we are creating a magnetic field by using certain components. So in order to start the experiment, let us nullify with respect to the Earth's magnetic field. So the nullification process is, without switching off any of the devices, you have to adjust this magnetic needle on aluminium pointer exactly perpendicular. So how can you adjust this? Means the aluminium pointer should show 0, 0 deflection on this magnetometer. So to make it 0, you can adjust either the magnetometer as well the arms of this arrangement. So I'll repeat, either by adjusting the arms as well as this magnetometer. First you should set that aluminium pointer shows 0, 0 deflection. So while adjusting it, you should be very careful enough. The only precaution in this experiment is, in this deflection magnetometer, exactly at the center there will be a mirror. So while adjusting, you should look on to the top so that your face should reflect on this mirror, so that there will be no parallax error while doing the experiment. So on looking into the mirror, adjust this so that it will show 0, 0 deflection. So suppose if it's not exactly coinciding, you can also adjust the arms. Means if we are nullifying with respect to the Earth's magnetic field on this particular spot where we are doing the experiment. So it is nullified exactly 0, 0, and this magnetic needle is perpendicular to the aluminium pointer. We have nullified the circuit. So 0, 0, see here. Next thing is, switch on the circuit or switch on the battery eliminator and adjust this rheostat so that the aluminium pointer now shows 60-60 deflection. So earlier it was 0 before switching on the battery eliminator. Now when I switch on, it's nothing but we have created a potential difference between the 50 turns of this circular coil, so that current starts flowing, and the maximizing current is by offering the lowest resistance to the circuit, so that the maximum current is shown by the 60-60 deflection in the magnetometer. So now adjust this rheostat so that it shows 60-60 deflection. See here, now it is 60-60 deflection. Now the first point you should take after getting this 60-60 deflection is, you need to check what is the amount of current passing through the circuit with this ammeter. So now if you see the ammeter deflection, earlier it was 0 because we have switched off. Now it shows certain deflections. See the red pointer on which black line it is getting coincided. So if you see that on the 5th reading it is getting coincided. The red needle is coinciding on the 5th division of this analog divisions. So the 5th division now can be taken as, the value of the ammeter can be taken as, you already calibrated that each division is 0.05. On the 5th division it is coinciding. So 0.05 into 5 is equal to 0.25 amps. So now the current passing through the circuit is 0.25 amps. Understood? Second thing is, you have to write the number of turns of the coil. So as we selected 50, let us take n is equal to 50. So by starting doing this experiment, we can say that n is equal to 50 turns. The current passing through the circuit is 0.25 amps, and rest of the readings, BE is already constant given as 0.38 into 10 power minus 4 Tesla. Mu naught is permeability 4 pi into 10 power minus 7 Henry per meter. So before doing this experiment, you should be very much attentive enough that these two are the MKS units, but when we come to the rest of the only two readings like radius of the coil and the distance, these are taken in centimeters. So you should be very careful enough that you need to convert those centimeters into the meters and start doing the calculations. Now I will repeat the aim again. So the aim, you know that variation of magnetic field along the axis of circular coil. So till now the point is how we have created the magnetic field. And now the next step of this experiment is to carry out the variation of magnetic field. So how are you varying the magnetic field? Means by varying this deflection magnetometer along the axis of the circular coil. So this is the axis and this is the circular coil. So this is nothing but now this circular coil at this point is now acting as a pseudo magnet. So you are exactly at the center of the pseudo magnet. So obviously the magnetic field strength will be very high. Means when you are holding a magnet and iron bar, when you are near to the magnet, the strength will be very high. Now when you move away from the magnet, the magnetic effect will gradually decrease. Now in which direction you are moving? Means along the eastward and the westward directions of the coil. So if I move here, this is eastward direction, and if I move along here, this is the westward and this is the axis. Now if I vary this deflection magnetometer away from the foil like this at every step, what is the variation and how will it be deflected in this aluminium pointer readings? That is what the purpose of doing this experiment is. The first part is to create the magnetic field, and second part is to vary along the axis in eastward and westward directions. So before taking the readings itself, by your understanding we can say that if you plot a graph exactly at the center of the coil, means exactly at the here, if it is, the effect will be maximum. But when you move towards eastward, 1 centimeter, 2 centimeters, or 2, 4, 6, or 3, 6, 9, depending on your convenience, if you move, this point is exactly at the center of the coil. When you move away from the axis, the effect will gradually decrease. That happens even in the westward direction. So the effect will gradually decrease. Now if I start taking the readings, how you know that are we moving 2 centimeters or 3 centimeters? Means see, when you come down to the apparatus, see here there is a mark over, and this should exactly coincide with the 0. Then you can say that it is exactly at the center of the coil. Now you need to take the readings. And if I want to move eastward, we can say that, for example, if I want to move towards 5 is calibrated, let us go 3 centimeters. So if I move 3, this line should coincide with the 3 centimeters on this axis scale. Now if I move 3 steps again, means second reading is 6. Next 9, like that I need to move towards from 0 to 5, 6 divisions ahead. Now start taking the readings. So I will get back to 0 again. So it should exactly coincide to 0. Now if you see here, as we have adjusted to 60-60, it is showing 60-60. So we have selected 2 keys. So the first deflection is 0, exactly at the 0 centimeters. Now one aluminium pointer end can be considered as theta 1 and second end as theta 2. So here theta 1 60 and theta 2 60. This means let us imagine that the current is passing in the one clockwise direction. The deflection is 60-60, theta 1, theta 2. Now the point is, how will you get this theta 3 and theta 4? Means just reverse the keys. Means we are reversing the current across the circular coil. Say let us suppose it is in the anti-clockwise direction. So now take the readings. See, it is around 55 and 55. So let us say theta 3 and theta 4, 55 and 55. Next, the average of all these readings is theta eastward. Theta E, suffix E indicates theta eastward, deflection along the eastward direction when the coil is at exactly center, means 0 centimeters. For the sample I am showing you, but we have already done the experiment. I will show you the entire readings in the next part. Only to understand how to take the readings, I am taking this part. So next thing is, we have reversed the flow. Now don't get confused like which is theta 1, theta 2, theta 3, theta 4. Don't concentrate on that, because we are taking the average of all these readings. So 2 readings before reversing and 2 readings after reversing. Next thing is, let us go for 3 centimeters away from the coil. So move 3 centimeters. See, this is 1, this is 2 and this one is 3. Exactly coinciding, 3. Now see the deflection. 55 and 55. So 3 centimeters, 55 and 55. Now reverse the case. We get theta 3 and theta 4. If it is moving like this, wait for some time and tap it till get stable. So 56 and 57, 57 and 57. So like this you need to take the readings for 3, 6, 9, 12 and 15. Similarly on the westward direction. So westward direction, how will you move the westward direction means, see here I will show you. First in this experiment you have to completely do on the eastward 3, 6, 9, 12, 15 and take the readings. Now come to the center again. From here move to the westward. Now 3 centimeters. Westward towards 3 centimeters. Tap it and show. It's around 50, 54 and 55. So 3 centimeters means the 0 will be common for all these. 54, 55. So the same readings we have to repeat here because 0 is same for eastward and westward. Now reverse the flow of current. It's around 55 and 55. Theta 3, theta 4, 55 and 55. So this is one sample reading. Likewise, if you do, I hope you have all understood how to take the readings in the eastward and westward directions. So we have already done one set of readings. I will switch off the device and I will show you the set of the readings that we have done in this case. So here, see, theta 0, 2, 4, 6, 8 centimeters from the center. So when it is exactly at the center, theta 1 and theta 2, 58, 58. So all our 58 center is common. Now when you move towards 2 centimeters, we get theta 1 and theta 2, theta 3, theta 4 westward. Take the average of all these 4 readings, you get theta E. Similarly, when you move 4 centimeters away from the center, the readings were 50, 50 and theta 3, theta 4 were 49, 49. Take the average of all these 4 readings, you get 49.5. Similarly, when you move for 6 centimeters, 45, 45, 40, 40. Take the average of all these 4, we get 42.5. 35, 35. 32, 32, average is 33.5. Now on the westward you get all this set of readings. So theta E is the average of all these eastward deflections. Theta W, this 58 is the average of all these 4 deflections in the westward direction. So this is 54.5 is the average of all these 4 readings in the westward. So there are lot of calculations here. So to avoid, you can see here, theta E is the average of all these 4 readings. Then you need to calculate tan theta E. This is the tan theta E tabulation. Similarly, westward directions you are getting theta 1, theta 2, reverse the keys theta 3, theta 4, average is capital theta E, then again you need to calculate theta W and again you need to calculate tan theta W, means tan of this formula. So how will you get this tan of that is, suppose if I say take this one theta W, see here average deflection, one more reading is average deflection. Average deflection is capital theta. So how will you get this capital theta means, this is theta E plus theta W by 2. Theta E plus theta W by 2. This is capital theta. We get it as 58. How are you going to get this means, this one is 58 and this one is 58. So average is 58. Theta E plus theta W by 2 is the capital theta. For this you need to find out tan theta. So tan of 58. Just switch on your calcs. Tan of 58, close the brackets. So tan of 58. How will you get? Means there is a tan function here. Tan of 58, close the brackets, and is equal to, it is 1.600. We have written here 1.600. This is tan theta value. Next thing is we need to calculate B. Capital B is equal to BE tan theta. Tan theta we have found in the earlier one, and we need to multiply it with BE. What is BE? Means BE is equal to 0.38 into 10 power minus 4, which is constant, that we have already explained. So now 1.6003 into 0.38 into 10 power minus 4. So if I multiply it with 0.38, I'll get the answer 0.608. Two decimals are enough, so 0.60. For our convenience, let us take this minus power, 10 power minus 4 as common. We are not multiplying it, keep it in aside only. So 0.60 into 10 power minus 4. So finally we have ended up with BE tan theta value. Like that you need to do the calculation for every deflection here. Whenever we move from 0 to 4, 6, 8, like that we need to do for all the calculations. So now why we are doing all these calculations is, the formula for this experiment is, see here, B is equal to mu naught Ni A square by 2 into x square plus A square whole power 3 by 2. This is the formula for the magnetic field that we are creating whenever we are moving away from the coil. Are we at 0 centimeters or 2 or 4? That is x. X depends upon where the position of the magnetometer is from the coil. So this x is varying from 0, 2, 4, 6, 8 like that. Mu naught is constant. N is the number of turns. In this case we have selected 50. I is the current that is passing through the coil, which is 0.25 amperes. Next A is the radius of the coil. So how we are going to find the radius of the coil means, it's very vague method we are doing. Take the wire and find out the diameter from end to end like this, and if I divide it, we will get the radius of the coil. So experiments are saying that radius of the coil is diameter of the coil by 2, so it is 20.9. From end to end it is 20.9 centimeters by 2, 10.45 centimeters. So 10.45 centimeters. So in the first step itself we said that A is taken in the centimeters, but rest of all the constants are taken in the meters. So we are converting the radius into meters. So 10.45 into 10 power minus 2 meters. Similarly, in the further steps, you have to convert this 0 centimeters, 2, 4, 6 into meters. Now, when you come back to this point, N is the number of turns, I is the current, A is the radius of the coil. Similarly, X is the position of the magnetometer from the center of the coil, and A again is the radius of the coil. Every time we need to substitute X is equal to 0, X is equal to 2, X is equal to 4, 6, 8, because X is varied. Rest of all will be constant. For every step we need to vary this X and find out the values. That is what we have done in the last tabulation. So substituting, I will show one calculation after that. Now we have to compare these two values. So this is the experimental value and this is the theoretical value. These two should coincide. Then we have done the experiment in sync. So this is the theoretical Earth's magnetic field which we have created here, and this is the experimentally created the magnetic field by varying the parameters. At every step these two should coincide. Now see here, it is 0.06, this is 3, but 10 power minus 4 is common. So these two are in sync, we can say that. So in order to understand, for let us say for 0 centimeters, how will you get this 3.0 into 10 power minus 4? See here, at x is equal to 0 centimeters, n is equal to 50, I is equal to 1 amp in this case, but for the first set we have taken it as 0.25, but rewrite it as 1 amp. A is equal to 10.45 into 10 power minus 2 meters. Now substitute the answer here. Mu naught is 4 pi. 4 into pi into 3.14 into 10 power minus 7. This is the fixed constant value. N is equal to 50. I is 1 amp. A is 10.45 into 10.45 into 10 power minus 2 into 10 power minus 2 becomes 10 power minus 4 by 2 into x is 0. So 0 plus A is 10.45 into 10 power minus 2 whole power 3 by 2. So like this we need to do the calculations every time, and finally we got 3.00 into 10 power minus 4. Now I hope you all have tabulated these readings and do the calculations, and finally whatever may be the variation that you are doing, these two values should coincide with each other. So the theoretical value and the practical value that we have created. This theoretical value is according to the nullifying point that we have created, and this is by varying the x value. So these two should coincide with each other, and we need to plot a graph. So tan theta value is common, tan theta w and tan theta e. We need to find it according to the tabulation, and when we plot the graph, 0, x-axis is taken the distance from the center of the coil, x-axis 1 unit is equal to 2 centimeters, on y-axis 1 unit is equal to tan theta 0.2, 0.4, 0.6, 0.8, so 0.2 degrees. So how will you get in the first class itself we said how to calibrate this graph. So calibration of the graph is nothing but here tan theta is 1.6, 1.4, 1.1, 0.8, 0.6. So it started from 0.6 to 1.6. So let us take the divisions as 0.2. So 0.2, 0.4, 0.6, 0.8, 1.2, 1.4, 1.6 is the maximum value that you got from according to our readings. So plot the graph. Now I will repeat again that in scale is very much important while plotting the graph. Scale is nothing but what is the value of each square box. It varies for every experiment. So in this experiment, the x-axis is the centimeters from the center of the coil. So that's why 1 unit we have taken it as 2 centimeters. On y-axis we have taken the deflections of tan theta. So 0.2 degrees tan theta. So now when you plot the graph, you get the graph like this. This shows that when the magnetometer is exactly at the center of the coil, we have the maximum strength. So that's why the deflection is maximum. But when you move away from the coil, the effect will gradually decrease. Like that it will gradually decrease. So the shape of the curve is inverted parabola, and this is what? Lot of calculations are there. The only precaution in doing the calculations is convert this centimeters. Wherever the centimeters are involved, you convert it into meters and do the calculations. So finally we have studied the variation of magnetic field along the axis of the coil. So we will give you the readings and you can do the calculations at home. Thank you.